Hey everyone, Anthony here, and today we're going to look at, I guess, more classical Python stuff. So we're going to run through some language concepts that will hopefully help it when you're reading someone else's code. All right. So the first thing we're going to look at is the concept of trueness and falseness. So we'll go with something pretty obvious. If 3 is greater than 4, print maths broken. WTF. Done. Else, print all good. So there you go, all good. So that should come as no surprise what this should do. It should not tell us that maths is broken. All right, so all is good. It's because this thing here evaluates to a true or false statement. So true, false. All right. Eventually, that's all it is. Everything else is just what do you do if it's true, what do you do if it's false. So that's all basic if-then statements. Nothing you wouldn't have seen before. But you'll also see other things in Python are testably true and testably false, right? So let's put that down. False. And you'll see what I mean in a second. So let's say we're writing something like, I just want to know how many nodes are being selected, right? So selected nodes equals Nuke selected nodes. Oops. If select to nodes print there are X nodes. Format X equals the length of the selected nodes. Okay, so that hopefully is readable right now. Oops, missing a close bracket, obviously. Right, obviously didn't print out anything. There are 3 nodes. Should be 5 now. Okay, there are 5. Obviously that works, but why does this work in the way it does? It's because I'm using this concept of testably true and testably false. So selected nodes is not a true or false value. Otherwise we couldn't get the length. There's no such thing as the length of true. That's crazy. Selected nodes returns us a list, and a list with nodes in it. So it's going to be, in this case I have all these nodes selected. Nothing selected gives me an empty list. An empty list is one of those things that's testably false, right? So if that is a false statement. So let's go back up to here. I'll change it instead of maths broken. That was true. That was false. All right, so that's considered false value. So that's where you'll see code people doing stuff like this, where you'll get a list of things, and that list could be full of stuff, or it could be empty. If it's empty, then you can either produce a message or you can just ignore it. So that's the if statement. That's if the list has something in it, it's considered true. If the list has nothing in it, it's considered false. That is also true for other types of data structures. So if you have a set, a set with nothing in it, then that's all. Oh, I should do it up here, and I'll do it explicitly. So list, an empty list, is false. An empty dictionary is also false, and an empty set is also false. So if you remember, so let me write these down. False is a empty set. Empty list. We'll add to these as we go. Empty dict, right? And obviously false. So what else is also testably false? Well, you'll see this other kind of thing where, let's clear that up. You'll see this other thing where I will do this. If the knob, right? So if the knob, then do something, print the knob. Ugh, can't type for shit today. Knob.value. Don't know if I'm actually allowed to swear on camera. Too late. And the knob equals, let's just grab the white off the grade node. Nuke let's just do selected node dot knob white. Okay, go. So no, put that up. Right, so that will print out the value of the gain on it, 0.21, and this one shouldn't do anything. Okay, so I'll put an else statement here, else print some junk. Cool. So you can see it's going through the second clause here. So the reason that's happening is because the none value is also testably false. So I'll just add that to the list, none. So the knob here, we know that the selected node knob white, we know the knob call is give me the knob. If you can't find the knob, just give me a none value. And that's why it's really useful, because if you ask for the knob, you don't want an exception because you have to wrap this with try except kind of clauses. You can just assume that you'll either get none value or something, and you can just test if it's none. So this is why this code here works. You can also do this amusingly, well, maybe not amusingly. No, you can do that directly. If none was false. You can also do it with the number 0. 0 is also considered false, which is another thing which you can use. You could say, going back to that number of nodes thing, so we just go nuke selected nodes, length of that one, if the len of print yay you had something selected. So I did have something selected. I had one thing selected. Click out. Nothing. It's because the number 0 is also testably false. In terms of testably true, pretty much anything that's not in that list. There are other things, and I can't remember off the top of my head, but those are the ones that come up all the time as core data structures kind of thing, because these are all really useful. You can build a dictionary and just have nothing in it. So you could have a loop which says, I'm building my dictionary, and then you end up with an empty dictionary, and you say, if the dictionary, do something. And if you don't have a dictionary, or if it's empty, your code will just simply go, all right, got nothing, moving on. So that's the idea of testably true and testably false. And you'll see this in if-then statements. You'll also see it in other constructs like you've seen me use with default values in a function. So let's say the value equals 3. Actually, let's just undo that quickly. The value is the oh wow, whatever. I'll just type it again, it's quicker. Right. So the value equals nuke selected node dot knob white. This has no error protection, so just bear with me. So value yes. All right. Okay. So the value is going to be 0.21. Or let's bring that up quickly. So let's look at the gain 0. Or there we go. Right. So the value is now going to be potato, because we've got 0 as testably false. So this is saying that get me the value of the knob. If the value of the knob is considered false, then use the backup value. So that's what the OR statement sort of does for us. And you'll see it most commonly in the code I write in terms of the function def do work. So if I have a do work function, I'd have how long equals none. So I have a default value like that, and I'd say how long equals equals how long, so whatever someone gave to me, but if they gave me a none value, 3 hours, something like that. So this is the same construct we're seeing here. It's how long is a variable, supply the value for none for default. If you don't give me a value, it will be none. Then I'm just say how long? Well, it's either the value you gave me. If you gave me something that's testably false, I'm going to consider it to be 3 hours. Be careful with this kind of structure though, because this is testing whether or not it's false, right? So what well, demonstrate it here. Print how long. Okay, so this function is not very exciting, but we'll do work. 3h. God. You know, it's what I supplied to it. Oops. Still a string, so I'm still supplying to it the string. 0. 0 is on our testably false list. So we might actually want to say do work for 0 amounts of time. So there might be some reason to pass that. So that is actually a common trap. If you want to do this with none values, you should actually be doing this. So it would be how long equals how long, so whatever supplied, if how long is none else 3h. That kind of structure, which is a neat little segue into ternary operators. Okay, so let's just keep that on screen. So I'll start with TCL, everyone's favorite. So let's do a TCL thing on the grade note here. All right, we're going to say, let's do the mix. Okay, so you would have seen this kind of thing. White greater than 1, yes, no. Or actually, let me do it. Yeah, all right. So as the gain goes changes, you can see the mix value changing there. I hope you can see it's going from 0 to 1. So that's a ternary operator. And we'll copy this TCL out and drop it down here. This is the TCL. TCL. And I'll get some more space so it's close to the top. So it's broken down into this kind of structure, which is the test, and then test. You need the question mark, value if true, the colon, and value if false. The syntax highlighting is making my life miserable. Let's see if I can make this a bit more visible. So the test. Yeah, test. The magic character. Something else, the magic character, and something else. Okay, so that's a TCL ternary operator. So you try to do this thing, and if it's true, you get this value, and if it's false, you get this value. So Python has the same kind of concept, which you saw just here. So let's write that on out. So Python's equivalent with the ternary operator is this. Red if true, else blue. Right. So the same kind of idea. We'll map this to, so this becomes, yeah, so this is more like value if true, then the magic, oh man, sorry, that's gonna be confusing. Value when true, if is the keyword, condition, should have done that first time around, else value if value when false. Right. So it's the same kind of structure, and I'll just make sure that you can see what the magic tokens are. If, else, something like that. So if you compare the two, TCL and Python have similar, well, they're actually the same concept. It just uses the question mark in TCL for the to denote everything before it is the test. In Python, it's saying if stuff else. It's everything between those two things is the test. TCL then says after the test, the first thing is the value of true, a colon, and the value of false. Python's is everything here and everything here. So it's value of true, test it, value of false. All right, so that's TCL and Python ternary expressions. Now, the interesting thing about this is we're going to deliberately break something, and you'll see I guess Python is lazily doing the work so you don't have to worry about it too much. So let's try something quickly here. So let's set up an actual breakage. So on the blur node, so we know the blur node, Nuke selected node, blur equals Nuke selected node. All right, selected node. All right, so I got the blur here. So the blur is the blur is the blur. We know the blur does not have a gain knob, doesn't even have a white knob. So let's just, you know, we asked for a knob that doesn't exist. The blur, the knob equals the blur, not that one. All right, cool. So that's going to be a none value. Okay. And let us try print the value. Oh, actually, no, I should do this white. All right. So I'm making this demo up on the fly. Okay. And then we want to do this. The value, okay, equals the knob dot value. And we want to print the value. Okay. So I'll make this break. This works fine when we have the grade node selected. Oops. Right, and if we have the blur node selected, it hates us, it breaks. Cool, fine. We want to print a default value of 1 or 20 or something like that. So let's use this structure we have and do that again. So we want to say the value is the value when the value when true. So when we can actually get the knob, then we want the knob value. So the knob value. We want to have our test if the knob. All right, because the knob is testably true if it's not none, so it's not going to be false. Else, and here's our default value. The value is, I don't know, 222, and then print the value. All right, so let's run that quickly. And the knob is the, right, the knob's white thing. So let's run that. So 222, and oops, working 0.32, and it works fine here. That should be 222. Notice how we don't have any error messages, and notice that if you were logically looking this left to right, you would go, wait, the knob value, how the hell do you run that? Because the knob is none. If I got rid of this here and just did this again, see how it's thrown up this value error? It's because this is just saying run this code straight away. So it's going to go, oh, well, there's no knob value. What we're doing here, we're saying do this only if the condition is true. Otherwise, do this backup plan. So TCL is probably better at expressing this because it runs the test. If the test fails, it goes straight to here. If the test passes, it goes here. In Python, it does the test first. If the test passes, then it does the front section. If the test fails, it does the back section. So you can have code that doesn't even need to care. You can have code like this, which is very concise. As long as you start being able to read this makes a lot of sense. Give me the knob value if the knob is found. Otherwise, just give me a backup value. Right? And that's quite a nice, succinct way to read it. And I guess I would start using this. I've been using this a little bit more over time as I've become more familiar with it, because to me it's a lot more elegant than this. If the knob value, if the knob, the value equals the knob dot value. Right, there's that. You put an else there, else the value equals 222. That's one variation of it, and the other variation would be this. Literally, we take that, we don't bother with an else clause, and we start with the default here. Right? So these, let's get some more space. So this form here is the same as this, which is the same as this, as in they'll get you the same result in this case. But depends on which you prefer and which expresses the thing you're trying to do more cleanly. This is, I kind of like the one-liner because it works well with how I think. This I used. So yeah, I think that's the majority of this one. It's quite Python heavy, but hopefully you'll find that a little bit useful, especially being able to read the TCL stuff and seeing that map across here, because you will see this TCL. A very common thing is I'll do actually what ZD focus. So you'll have your ZD focus, and then you'll have it on the disable node, and then you'll have your expression here, which is $GUI. So if you're in GUI mode, then disable it. Otherwise, turn it on. So that's how you get the $GUI disables. If you're wondering what that magic, I'll actually edit expression, put that out here. Yeah, if you're wondering what that magic kind of stuff is basically test it. Are you in a graphical environment? If so, then turn yourself off. Otherwise, turn it back on. You'll see that on the ZD focus, and you'll also see it on the switch. Exactly the same thing. So it'll be if you're let me just use the handy dandy blur, like and ZD for all right. So that's all it is. If you are in the way around, if you're in GUI mode, use the cheap blur that approximates the ZD focus. Once you're no longer in GUI mode, you're rendering on the farm, then use the heavy, more accurate but expensive, but more accurate but beautiful thing, right? And that's a TCL ternary operator. You could do this in Python if you wanted as well. So for good form, change it to Python. I actually don't know what the Python equivalent of $GUI is. Nuke GUI, I think that's it. Nuke GUI. One if nuke GUI else 0. So that's the same idea. You'll have to just find help nuke GUI. I'm pretty sure nuke GUI is fine. Check whether that's just because it's a number here. This is it's just a Boolean thing, right? So the help documentation doesn't tell us what nuke.gui is, but I'm pretty sure nuke.gui, when you're in terminal mode, will be false. In fact, let me pause and check that. All right, so I'll just run this up. Nuke.gui, false, yes, cool. So yeah, you can use that exactly the same way if you prefer Python, and it's 1 or some value if nuke is in GUI mode, otherwise 0. So yeah, hopefully that's all helpful and useful. It's a little bit boring on the node graph, but sometimes you just have to work in text, unfortunately. So yeah, let us know how you go with it. If there's any other kind of things, even if I know I mentioned Python, but if you're interested in some of the TCL stuff, let me know. TCL's kind of cool, but it does my head in every now and then. So if it does my head in, I'm sure it does someone else's head in. So yeah, let us know if you've got any examples and I can break down some TCL as well. All right, talk to you guys later.